So absolute value inequalities are going to go very, very similar to absolute value equations. It's just going to be a little bit different at the end and maybe a little bit in the middle. So what we're looking at here is that we're 3 away from the 0, just like absolute value usually is. So we're looking at 3 and negative 3. Okay, and so you'll notice that we still have a positive 3 and we still have a negative 3, so I've got to split them up. What's different though is that this is saying the absolute value is less than 3 away. So the distance is less than 3 away. So it could be anywhere in here up until you get to 3. And it could be anywhere in here up until you get to negative 3. That distance is less than. So we're going to be pretty close to 0. And so when we split this up into a positive 3 and negative 3, the positive 3 is going to go just like as if I didn't have an absolute value. And I'm going to write x minus 4 is less than 3. That's normal. But then when I go to the negative 3, I'm to the right of it. That means I'm greater than. So just like when you're multiplying or dividing by a negative, you have to switch the sign. Notice the sign is different when I do the negative 3. Then I solve each one separately. So add 4 to both sides. So x is less than 7. And I go over here and add 4 to both sides. And I get that x is greater than 1. And so the last part of this is that you have to know if this is an and or. This is a compound inequality, and I have to have the word either and or in between. I need to signify which one that is. Now, we normally don't have this picture, so I can't tell that it's going to be an and. So what we can do is we can graph it. I can put the 1 and the 7 on the number line where they belong. X is less than 7, so it's an open circle to the left. X is greater than 1, so it's an open circle to the right, and you'll see that they overlap and connect in between, and that's the picture of an and. So when I'm correcting this, I'm actually looking at all of this right here. I'm looking at the inequalities, so I'm looking at the x is less than 7, the x is greater than 1. I'm looking at that you picked an and I'm looking at the graph that it's correct. So you want to make sure that you have all of those things when you do that. So the only other thing to look at is if it's a little bit more complicated, but really it's the same as equations. I have to get rid of the 3 first because I need the absolute value to be by itself before I split it up. So I have 2x plus 1 still in the absolute value. The negative 3 cancels with the positive 3 is greater than or equal to 9. Now I split it up into a positive 9 and then the negative 9. But then I have to switch the sign when it's negative. Okay, now we solve. Subtract 1. 2x is greater than or equal to 8, divide by 2, x is greater than or equal to 4. Go over here, subtract 1, 2x is less than or equal to negative 10, divide by 2, x is less than or equal to negative 5. So if I need to figure out whether it's and or, so I'm going to graph it. Hopefully you have more room than I do, but we have negative 5 here at the bottom and a 4. X is greater or equal to 4, so I'm going to close the circle, greater than goes to the right. X is less than or equal to negative 5. I'm going to close the circle and go to the left. And it looks like an or picture, so I'm going to say this is an or problem. Okay, now if they both went in the same direction, if both arrows went in the same direction, you did something wrong and you need to go back and check your work because they will not go in the same direction if you do it right.